Alright, so this is the Admiralty Secondary paper 2 question 6. So for part C, they want the, what do they want? They want the total distance traveled by the particle in the interval t equal to 0 to t equals to 5 pi over 12. Okay, so let's understand the question first. They want the distance, right? So in order to find the distance, okay, so what do we know? They want the values of t when the particle is instantly at rest, right? So if we look at from part A, we know that from part A, we know that the particle is instantly at rest at time is pi over 12 and 5 pi over 12. So what does this tell you? This tells you that the particle stopped twice. Understand so far, right? Because why did the particle stop twice? There are 2 times here, right? Pi over 12 is 1 here, 5 pi over 12 is another 1. Understand so far, yeah? Okay, so moving on, we know that the particle stops at t equals to pi over 12 and 5 pi over 12. Okay, so we know that in order to find your velocity v to your distance to displacement, but displacement and distance is the same thing. Displacement is just a vector quantity s. Okay, we have to integrate it with respect to time. Yeah, so basically integrate v respect to time. Okay, so I'm going to show you the integration method. So in velocity v to displacement or distance, we have to integrate the velocity with respect to time. Okay, so given by the question, we know that v equals to 3 minus 6 sine 2t. So if we know that velocity is 3 minus 6 sine 2t, what do you know? Let's find the total distance. But in order to find the distance, we are going to integrate first. Okay, so we will integrate. First thing we will find distance when the time is pi over 12. So integrate from pi over 12 to 0. 3 minus 6 sine 2t with respect to time. Hold on, my t I write properly. And then we plus the integration of I'll explain why later, but just hear me out first. When 5 pi over 12 and pi over 12. I want you to know that I'm using this rule here, which usually teachers will not teach. It's the integration of AB plus the integration of your C and your A. Okay? Hold on. This is a technique which you can use and it is allowed. So I'm just going to write example AB with respect to X plus integration of your CA with respect to X. This is equivalent to your integration of your CB with respect to X. Okay, so if you look at this, right, I will think about it as the A and the A cancel out here. So that's how I get integration of CB with respect to time. So if in this example, if I were to use this, right, this will be also equivalent to your integration of 5 pi over 12 to 0. So this is when the distance is from 5 pi over 12 to 0. Understand? Okay, I'll put the equal sign back. Okay, but I'm going to write the rule again so that you can copy it. So 3 minus 6 sine 2t respect to time. Okay, so this, what is this for? So this is the distance when from t equals 0 to t equal pi over 12. Okay, second distance here is from t equal pi over 12 to t equals to 5 pi over 12. Okay, so basically, because why? They say that the particle stops 2 times, correct? So this is how you will get the distance via the integration method. Or you want to draw also can, but personally, the integration method is faster if you can really understand the question. So I'm going to integrate now. I'm going to write at the bottom here, okay? This is equals to, you integrate 3 with respect to time, you get 3t minus 6 sine 2t. Sorry, integrate sine, you get positive, negative cosine. But negative times negative is positive. Positive 6 cosine 2t over 2 pi over 12, 0 plus the same thing lah. Okay, but I'm going to simplify it, okay? Because 6 cosine 2t over 2, essentially, it is the same as 3 cosine 2t. Plus the same thing again, 3t plus 3 cosine 2t, 5 pi over 12, pi over 12. Okay, understand the context of the question here, yeah? So they say that what? Why do I do this? You might wonder again, I want to repeat this again. Why do you integrate from pi over 12 and 0, and then you add the integration of 5 pi over 12 and pi over 12? This is because, right, first distance is from t equals 0 to t equals pi over 12, because pi over 12 is where the particle is instantaneously at rest, and we integrate from 5 pi over 12 and pi over 12 because this is the distance from t equals to pi over 12 to t equals to 5 pi over 12, where t equals to 5 pi over 12 is where the particle stops at the second time, and that's what the question wants. So in order for us to, and this is how, and this is why we integrate it in this format, and also about the rule here, which I'm going to write it out soon. This is also the rule of integration of AB with respect to x plus the integration of CA with respect to x. This is equals to integration of CB with respect to x. Understand so far? So if I were to work this integration out to get the answer, okay, I will write this is the same as your 3 bracket you know, I'm just gonna write this out because you need this step out. And now this is the second one, second integration. So plus your 3, just spam this into the calculator, but don't make any careless mistake. Okay, so when I get this answer, right, this will be equals to 0.384 plus minus 0.24055, because note that this negative here is indicating the direction. So don't be confused, this is equals to positive. So take it as a positive because remember, displacement is a vector quantity. It have both magnitude and direction. So 0.3834 plus 2.054555, take it as positive because negative just indicates the direction. It doesn't mean that the distance is a negative answer. Therefore, equals to 2.44 when it's rounded off to 3SF. No need to write units, but in this case, the distance is meters. Understand?